I'd like to introduce our guest for the Microsoft Power BI UK user group session today on why is my Power BI report slow? What should I do? It's no other than BI Guru, 1/4 of the DAX men, as I'm led to believe now, and the elite top tier SSAS, Tabula, DAX, Maestro, Marco Russo. And hopefully that introduction was as fitting as I could make it.
It's too much. Thank you. Thank you very much, Leon. Thank you very
Thank
much.
you.
It's a pleasure to be here. Yeah. It's a pleasure to be here. I look forward to be back in London soon, I hope. But okay, for today, it's just remote.
Yes, indeed. I think that makes two of us not being able to commute at the moment. It's it's very much the four walls of our house. Mm-hmm. So I know, Marco, prior to this session, we were able to provide you with some questions. So thank you very much for giving us access to the YouTube video, which was very insightful. Yep. And we had some fantastic questions off of the back of that. And as I say, throughout the session, if anybody does have any further questions they want to ask, then please do within the chat. And we can kind of start off, if you would like to, Marco, with moving through some of the questions that were posed to you prior to the session.
Yep. Okay, so but in general, I would say if someone has questions to ask, you can write in the chat window. I have a number of questions I received in advance, and I'm going to get from them. But at the same time, if you have questions about what you have seen in the video or what you want to know about performance Power BI optimization, just ask. You might want to, if we need more details, you might turn on the camera and ask us so that just we try to not have too many feeds at the same time. And I think I can start. Fine?
Yes, fantastic.
Okay, so I just got an order. So the first question I received is it best to call measures within parent measures or redo the logic? And okay, that's an interesting question because apparently I would say no, but as usual, it depends, right? Let me, I show the screen one moment. So I try to show an example of what I can write to explain the question and to explain why it depends. So let me just find screen sharing here. Here we go. In screen number 2. Okay, so let's say I have here, I create a measure, right? So I go in a model here and I create a measure. It could be a simple measure like sales amount equal to, we have some x of sales quantity multiplied by price. Now, the question is, if I create another measure, so this is sales amount, is a measure I have. Now I create another measure, and this measure is like, for example, let's say margin. Okay, margin is equal to, let's say, sales amount. Let's say sales amount multiplied by 0.25. Okay, it's a stupid formula, I know, but the idea is that is there a difference between creating a measure that depends on another measure or by replacing this measure with the original measure, which is some x, blah, 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 right? Now, there is no differences. Actually, there is a difference. If you want to replace a measure, you should write calculate. And then inside a calculate, the content of the expression you have in the other measure. But at this point, there will be no difference because in reality, every time you have a measure reference, the measure reference is translated exactly into this one. So we have a feature in, so let me write this measure this way. I'll show you another thing. So if I have sales amount here, and I go in DAX Studio, and I go in DAX Studio now, okay, 1 second, and we open DAX Studio. It's just opening here. Here we go. So DAX Studio has a feature here. When you go, for example, in this margin measure, you can right click and you say, I want to see the measure definition, right? And the measure definition is the measure definition of margin. But you can also use this other feature, define and expand measure, which translate every measure reference into the corresponding calculate with the corresponding measure. So here you see that we have the calculate sum x multiplied by 0.25, right? So this is what we expect to have. So the calculate finishes here, because this is the measure reference finishes here, and then we had the multiplied 0.25. So the original measure margin can be translated into this one, and this is the same thing that the engine does. So the first answer should be, no, there are no differences. But you have to be aware of redundant conditions that you might have. Guess what? If I have in Power BI Desktop, let's say that we want to apply this if sales amount is greater than greater than 100. Okay, if this is greater than 100, then do this. Otherwise, the margin is 0, right? Something like that. Now, at this point, we have a condition here. Now, so far so good. But now imagine you create another measure, and this other measure has, let's say, margin percentage is equal to, and I rewrite the if, right? If I rewrite the if the sales amount is greater than 100, then I get the margin divided by the sales amount. Otherwise, I want just to show 0 or something else. Now, at this point, if you look at what I'm doing, this condition is repeated several times. And if this condition is repeated several times, then it becomes a problem, because the measure we will obtain in, sorry, I have here a request that is not a good idea. So let's go here. So if I go here and I go to margin percentage and I click here, right click and define dependent measure, you see that sorry, not this one, define and expand measure, the expand measure, you see that when I look at the code, wait, okay, so just to have something, okay. Now, the reality is that when you have when you have many measures nested each other, it happens that you might see the same condition repeated several times. Now, this is a problem. So nesting measures is not a problem by itself, but the issue could be that you repeat conditions that will not be optimized by the query engine. And so this is the real challenge. If you know that embedding measure, you embed a lot of conditions that you write just to protect your measure to display something bad, that could be something that repeated multiple times could affect the performance in a negative way. Otherwise, no differences. Just the measure reference by itself is not something that by itself can create a performance issue.
Fantastic. Thank you for wrapping that up for us, Marco. I think that gets asked quite often. If it's okay with you, should we go to a question from the chat?
Yes, of course. We can alternate, so we can, use these questions as a, backup for when we don't have new questions.
Perfect. Okay, so this question's from Ramon, and he asks, how can I pass one or more filter contexts in DAX Studio to evaluate behavior that the measure will have within the Power BI environment?
Okay, so in theory, this is not necessary. Let me show you why. Again, we can go back to the window here, and I show you this. Let's say that now I have two measures, and I create a matrix here. In this matrix, I include the measure sales amount and the product brand. Then I include the customer country in filters here on the page, and I increase the font here just to make it more visible. 1 second. And sorry, grid. Where is the grid? The grid. I lost my. Here we go. Grid, and I use 20. Something like this. Okay. Now, I also want to filter Australia only. Here we go. Now, the filters I have here are already defined here. And if I have for example, a slicer, I also have, let's say, the city, right? And the city, I filtered this other city. And for this city, we have this visualization. Now, when I go in View and Performance Analyzer, I can capture here the queries, like what am I displaying in the matrix? Like copy the query. When I paste the query here in DAX Studio, you can see that first, if I run this query, if I just run this query and I look at the result here, you see that I have exactly the same result. Sales amount filtered by using the same slicers and filters I defined in the report. Now, if you look at the initial part of the query, you will find these variables that are filter, 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 filter. So the definition is always in a variable that usually starts with 3 tags, or it could be a filter when you filter by a measure. Imagine you filter the customer by using a measure. Every one of these filters is a variable defined here. And this variable, which is a table with a list of values, is used in the following instructions to apply the filter. So the easiest way to apply the filter that can be applied in Power BI is just to capture a query in Power BI. Because otherwise, the alternative to that is that, let's say that you want to just analyze sales amount. How do you analyze sales amount? The easiest query you can write in DAX is this, right? You write evaluate, then you create a table that has 1 column, 1 row, the value of sales amount. But this is sales amount for the entire model. You want to apply filters, you just can write calculate table, and then you keep this as is, and in every argument here of calculate table, you can apply filters. Like, for example, I want the customer country equal to Australia. And I press run, and now I'm filtering by Australia. And so you see the value now is smaller. Then I say country in Australia and maybe another country, which could be, now I don't remember where we have data. Let's say France. Not sure we have data for France. No, we have data. So we have a different number and so on. And you can continue. You can write comma and you can apply other filters. But to be honest, I usually use this technique because this is more, more realistic, especially when you have complex filter derived by applying a measure as a filter in a slicer and something like that is more realistic also for a performance. I hope this answered the question, but
yeah, I think it definitely did do.
Good. Okay. Do you want to move forward with another question from the chat?
So the next question from the chat is actually one that you've been asked via email, I'm pretty sure. And this one is, for better performance, is it always better to use count rows or distinct count?
Oh, yes. Good point. So let's see. We can see this here. So let's see. Oh, this doesn't disappear. Okay. So how can we see, how can you show that? So the question is about, let's say we have a measure like this one, define measure, let's say customers. So let's create sales customers is equal to distinct count of sales customer. Sales, come on, customer key. Okay, and with this measure, I'm using the studio because I want to show you the performance. Okay, so with this measure, I evaluate for every, let's say, country. Yeah, country. So let's use customer. So let's use summarize columns and customer country. So for each country, we want to see how many customers, let's say, we have. So we use this, customers. Okay, so if I didn't make any mistake, I try to format a query and run it, and I see the result, right? Now, we are counting how many customers had at least one transaction for each country. Okay, this is the calculation we're doing. So we are not counting how many customers we have in the customer table. We are counting how many unique customers made at least one transaction in the sales table. Now, I can write this measure in a different way. So let me rewrite this measure. And let's call this number 2. So we create another column here, number 2. And come on, the keyboard today doesn't help me. And I use this customers 2 column. Okay, so let's use the short line. So we go to a new line. Okay, so now instead of distinct count, I could use the question says count rows of values. Okay, this is the question. So the question is it faster or better using distinct count or count rows values? Now, if I execute this, okay, you see that the result is the same. So the real question is which one is faster? But before going deeper in which one is faster, the real issue is that these two expressions are not the same. Distinct count doesn't correspond to count rows values. It corresponds to count rows distinct. Okay, now we're talking the same language. Now, most of the times the result is the same, but distinct and values not always return the same value. In this particular case, for this particular structure, for this particular table, the result will be always the same. But when you use a column that is placed in a table that has a one-to-many relationship with other tables, that table could have an additional blank value that is ignored by distinct, and it's considered by value. So the difference could be one more value in values than what you have in distinct, and distinct count uses this semantic, right? So the result is always the same if we use this. Now, between these two expressions, there is no difference in the query plan. Let me show you why. If I just use one of these two, let's enable the query plan and the server timings. Okay. So once I have the server tables, the query plan and server timings available, when I run this query again, and remember now I'm executing the query with just one of the two measures. Okay. We can see here what happens. So usually we don't look at the query plan because it is too complex, but in this case it is just 4 rows, and you see a group semi-joins, pool iterator, project pool, cache. The cache corresponds to this query, which is an XM SQL query that asks this: select customer distinct count from sales leftover join, and etc. etc. Let's try to use the number 2. So now we use distinct count. Now we use the number 2, which is written in a different way, but it generates the same identical storage engine query and the same identical query plan. So this is just syntax sugar of count rows distinct. It is the same thing. Internally, even though we write a different structure, but internally it is translated into the same query plan and to the same operation. So there are no differences.
Perfect. Very similar to case and if functions in T-SQL then by the sounds of it.
Yeah.
Perfect. Okay, so that's let's take that as one from the email, and let's go to the next one from the chat, if that's okay.
So yeah, I have a question about is there any performance difference between GUID, Global Unique Identifier, and integer keys in Power BI? So the quick answer is that there are no differences, because when you import a global unique identifier, let's say that you use this in a, usually I see this GUID used in relationships, just because you import data, for example, from Dynamics, and they, or many other cloud environments have these global unique identifiers that are keys in tables, and they are used in relationships. Now, these are long strings, even though technically they are a sequence of numbers, but usually they are used and they are imported as strings in Power BI. And as a string, it is never used internally into the data. The storage engine converts every string into an integer, right? Because we have a dictionary for every column. The dictionary is a list of the unique values that is stored in a separate area of memory, and the data is replaced with a corresponding integer. So at query time, when you use the column just as a join between two tables, you just use the relationship, the original string is ignored, and the performance is identical to what you would obtain using an integer. But because you're importing these global unique identifiers, what happens? First, when you refresh the model, you have to read these long strings in memory. This requires time to read the data, and it requires time to populate and maintain the dictionary with the list of the unique values. Second, these long strings are stored in memory too, and these strings are not compressed. The only compression you have only one instance for each string. But you can imagine that in the table where this string is a primary key, it means that for every row, you have this long string uncompressed in memory, plus the integer in the data that then is compressed. But at this point, there is not much compression having a list of unique identifiers. But if you use this column in a relationship, you don't have this dictionary in one table. You have this dictionary in two tables, the one side and the many side of the relationship. So what happens when you have these models? You end up having a lot of memory consumed by these big dictionaries, because these strings are long and are not compressed. So yes, if you can replace in your data source the global unique identifier with an integer, and you don't import the global unique identifier at all, then it makes sense to use the integer. But if you, for any reason, have or want to import the global unique identifier for other purposes, then it doesn't matter. Just keep it as is, because there is no advantage in creating an additional column. So if you replace the column and you don't import the column at all, you save memory. Performance and query time is identical, but you save memory and the refresh time is shorter because you have to process a lower amount of data. If you want to keep that global unique identifier, then just keep it as is.
Perfect, thank you.
You're welcome.
I think what we'll do, we'll jump into the chat and we'll go on to the next one, which is from Ramon. And he says, I have to do a dynamic ABC analysis of a table with 105,000 products. I have tested it with DAX, with a DAX pattern that appears on your SQL BI website. But as you say, the performance is very slow. 80,000 of the products now have no sales, so it would be nice not to load them. But it could be that they have sales soon and they should be loaded when they do. I will try to do this with a list in Power Query using list.buffer and a filter, but is there another solution to be able to do an ABC analysis with a good performance?
Now I should review the. Let me share the screen one moment, so we can try to think about this one moment. So I'm gonna open the DAX pattern we mentioned. So if I go in DAX measures.com. And we go to the ABC, we go here. And we go to the ABC that is here, ABC classification. So let me explain where is the problem here, the performance issue. So this calculation, so let's say that I assume that you're using the dynamic ABC, because otherwise the static ABC pre-compute everything. So I don't think the problem is there. So you probably are using the dynamic ABC classification that evaluates everything in memory. Now, if you look at this code does the following here. So we have this initial sales by product. So this part, the row from row 2 to row 6, this is the initial preparation of the amount of sales for every product. And the following steps basically reuse this result multiple times. Now, if you have 100,000 products, this means that technically every time you execute this measure, a table with 100,000 products is generated dynamically in memory. But then if you, depending on the visualization you have, you might have to multiply these 100,000 products by the number of filters you have in the table. For example, imagine you have country. So you're doing an ABC by country. So for every country, you have to get these 100,000 products by sales amount. But because, you know, this is a dynamic, right? So it's a dynamic calculation. Now, if you know, Marco, 80% of these products are 0. Now, the way the measure is written now is computing the data for all the products, also those that have 0. What you could do is to ignore. By ignoring, I'm saying you will not assign any classification, not even a C, unless you write some, you know, some other business logic, by reducing this table product. Now, the use of all selected here, all selected is here because this generates an expression that is invariant for all the cells you have in a visual, probably. Because no matter what you change in the visualizations, if you have just product categories, for example, they are ignored in this calculation because you want to do the ABC for all the products, right? But you don't want to include those products that have no sales. So you might think to apply a filter here. Let me just write. Now, I don't have time to complete the analysis, but I just want to show you in DAX Studio how I will try to study the problem. I know that this table is too large, so what I can try to do is trying to reduce this to those products that have no sales. Now, problem is that products that have no sales, yeah, product have no sales. If I compute the sales amount to do that is too expensive. So an easy way to do that, an efficient way to do that would be the following. I write a calculate table where I use the all selected as a parameter here. And so as a filter, and here I want to calculate the table that is a result of summarize of sales, and then I want to use a product. Now, I cannot write a summarize this way because summarize requires columns. So I should include here all the columns of the product table, or at least the columns that I use in my calculation. But because product key is a primary key, I think that this could work. The only problem, I don't know, I don't remember the remaining part of the calculation. Maybe that if I don't have all the other columns, I have some other side effect in the context annotation later. So if you want to be sure that this will work, you just have to include all the columns of the product table following product key. This way, it is guaranteed to be the same. By doing that, you should get all the products. And if you want to avoid a different evaluation. So from a performance point of view, I would suggest you to remove all the other filters. So if you write a remove filters for date and for every other dimension you might have, that could be another good idea, because this way you have a smaller result here that is invariant in the visualization, and then sales amount is evaluated in the original filter content, which is what you want for the correct calculation. So yeah, this could be an approach. So the idea is that you have to apply the reduction as soon as possible in the calculation. I don't know if it works, but this should be the way to investigate in the problem.
Fantastic. I think that answers the question, or at least gives something to.
Yeah.
Yeah, exactly. Okay, perfect. Do you want to jump back to the email for the next question, Marco?
Okay, so I have a question about what is the best way to construct a model that has more than one fact table. Oh, yeah, okay. So I can share my screen, and here we go. And let me try to describe this using the whiteboard. Okay, so the problem is the following. So let's say that we have when we talk about star schema, we talk about something like that. We have a table here in the middle. We call this table a fact table, and then we have other tables here that we call dimensions, like this, 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 and this. So let's try to give a name. So this could be product. Product. This could be date, and this could be customer, and this could be sales, right? So usually the relationships are defined this way, and this is a one-to-many relationship, one-to-many relationship, one-to-many relationship. We call this a star schema because it's like a star, right? You have the center of the star is the fact table, the other, arrows of the star are called dimensions. Now, what happens if we have another fact table? Now, first of all, the other fact table probably has data that we are interested to analyze and compare with other fact tables. And an example could be purchases. Purchases, right? Let me just move this here. Oops. Here we go. Now, probably I have suppliers. And suppliers have nothing to do with the sales. So I think the suppliers will be connected this way. So one-to-many, no problem so far. But if I'm buying products in a certain date, I have to just connect this table, this fact table, with the corresponding dimension. Now, in dimensional modeling, this is a model that has conformed dimensions, which means that the dimension is shared on two or more fact tables. So the dimension product is identical for both sales and purchases. Sometimes it happens that you might have a few attributes that are only relevant for the purchases, but nevertheless, you keep those attributes in the product table, even though they don't make much sense for the sales, right? Otherwise, you have to create a specific dimension for the purchase, but it has to be separated from the one that you use for the sales. And if you do that, you no longer can compare the data between sales and purchase. Clearly, suppliers is an attribute that is not shared by the sales table. Now, are we doing a star schema now? Yes, of course. These are two star schemas that have two shared dimensions. And it is absolutely a normal condition. Is a regular condition, is the best way to design a data model in Power BI. Because when you design a model this way, you have good performance and an easy way to compare data, at least for the dimensions that can be comparable. Because you cannot compare the purchases by the customer and the sales by the suppliers, right? Unless you have you are just a box mover and you track the supplier also for each sale. So if this happens, you simply have another relationship here. If this is possible, it means that in every transaction, imagine that you track the single individual box and you know exactly the supplier for that material, for that component. That's fine. Many businesses can work this way, but in other businesses, you no longer you buy elements and then you build something and you sell something else. You're not able. You should track too many suppliers for a single box that you sell, and so it would be impossible to do that. But again, the model is just a representation of the business entities you have, and the idea is just to follow these simple rules. So the fact table has the events, the dimension has the qualitative attributes of the events, and the dimensions that are common to two or more tables are just called conform dimensions. Of course, okay, there are other rules that we don't have time to explain, but in general, it should be an issue to do that.
Yeah, exactly, Marco. And if anybody does want to elaborate on that subject, I've linked to the Kimball group. So Kimball is the best place to get some more information on this subject, definitely.
Absolutely.
Okay. We'll jump to a question from Nafomi, and they ask, what is the difference between generate and cross-join table functions in terms of performance?
Well, we're talking about two different functions because generate, we talk about two different functions that could be used for similar problems. Let me explain. Generate is a function that iterates the first argument, and for each row of the first argument, it executes the expression in the second argument. In SQL is like a cross apply. Okay, so if you write generate in DAX, in Transit SQL you are writing a cross apply, where the second expression is executed several times and the result is joined with the row that you are iterating. When you use cross join, you have two individual expressions that are evaluated only once, and you create all the possible combinations of the two tables, right? So imagine you have the two expressions return 10 rows, 10 rows. Result is 100. Now, if you have two independent expressions and you use them in generate, you obtain the same result that you would have obtained in cross join, because if the second expression cannot use the row context obtained by the first expression during the iteration, the result is the same. But what you're doing, you're executing for 10 times an expression that always returns the same values, and you obtain the same as a cross join. So I would say that using generate to do what you can get with a cross join is slower. But you should use cross join when you don't need a generate, and you should use generate when using the generate result in, exactly what you want to obtain, because you have an expression that depends on another. If you have two independent expressions, you just want to do the cross join, just use the cross join. Otherwise, you generate, but generate should have some dependency. Otherwise, it doesn't make sense.
Yeah, so it depends, but use the right function for the right. Yeah.
Correct. I would not say, because there is one case where we can say we can use both, and it is when you have two lists of values that don't depend on each other. And then if you use cross join, it's faster, because if you use generate would execute for n times the second expression just to get always the same result. It doesn't make any sense.
Yeah, that's fine. Okay. We've got a few more questions in the chat, but I'm keen, Marco, if it's okay with you, because the email questions came in first, if we can give a bit of precedence to a couple of those.
And we just have a couple of questions in the predefined questions, so we can move forward.
Okay, perfect. We've got one from Francisco Gutierrez, and they ask, is there any difference linking tables, so creating a relationship between tables, if data types are whole numbers or text?
Can you repeat the question? I'm trying to understand. Okay, I see the question now.
Okay.
I think that the question is similar to what we already discussed before. So when you say linking tables, I suppose you mean creating a relationship between the tables. And if this is the question, then the answer is that there are no differences, basically, because most of the times, even though you use a number, a dictionary is created to replace the value with a smaller value, because usually the range of values used in a dictionary is a smaller number of bits, but it doesn't make any difference. The only difference, if you use a text, the only difference again is the dictionary, and that could be a big cost. But again, usually I don't care about this problem unless I have a very high cardinality number of unique values in the column. Because at that point, if you have this, the text that I have in the column results in a large dictionary, and I may want to save memory. But removing the text could be expensive because you have to move part of the data preparation outside of Power BI, and this could be expensive. So it depends, right? So in general, I use what I have at this stage. I apply transformation for the data, but this is not the first problem I have. The first problem I have, I want a star schema. And if I start with a model that is not a star schema, my first concern is how do I get a star schema that represent the entities that I want to analyze? That is my first problem. Then for the performance, we can discuss, but you will never see a huge difference by changing the data type of a column used in a relationship in performance. The only difference could be per memory size, but mainly for the dictionary, not for the data type.
Okay, and just picking up on one of your comments there, Marco. So if you were introduced to a client and they had a snowflake schema, would you look to work with that first and foremost, or would you look to condense that or denormalize into a star schema?
If there are no reasons to keep the snowflake schema, I will denormalize the tables to regular dimension with a simple star schema. Sometimes the reason why you might want to keep the snowflake schema, let me show you an example. I go back to the whiteboard.
Okay.
And so here, no, sorry, not this one. I made a mistake. That would be, what am I sharing now? Let me check. Screen 2. Here we go. Okay, so let's see, what can we do here? Let's say that I want to clear this. So I have, okay, I want to clear this because I have here another table, which is the category. Okay, product, category. So if I have this situation, one too many. Okay, if I face this problem, right? So I have, look at this, I have this fact table, this dimension, and this dimension. This is another dimension. These two dimensions form what we call a snowflake schema. So we have more than one relationship in a chain from the fact table to the last dimension table we see. We call this a snowflake. So if I have this situation, I'm pretty sure I just denormalize these two tables, product and product category, into a single one. Okay, I will do that. But if I have this situation, then as usual, we say it depends, right? Because if I keep the structure as is, it's easy to create the model in Power BI, because these are just one-to-many relationships. And I have a model that doesn't allow me to drill by product the purchases, right? Because if I filter one product, I'm not filtering the purchases here. Now, let's say, so if I filter one product, the filter propagates here, but it doesn't propagate to this other table, unless you apply here a bidirectional filter. Now, this bidirectional filter is very dangerous, very dangerous. So don't do that. But if you really want to do that, at this point, it is much better, once again, to denormalize this into a single table and to create the connection here using here the column that will be, you will have a column here with a category, and this will become a many-to-many cardinality relationship with a single direction here. Then this will be much better. In general, the star schema is better, and I will not use the snowflake schema unless I'm, really in a hurry. I don't want to not waste, but I don't have time to fix the model, and I just want to see the report, and then I keep the snowflake schema. But usually, if I can do this kind of activity, I can do this kind of denormalization into a single table is better, even though at the end I might have a relationship that I don't like much, because I don't like much this relationship. But if the goal is to enable this kind of analysis, this is a price to pay, not just for the performance, but for the fact that now I have a measure. All the measures in this table are no longer completely additive for the product dimension, which could introduce other problems. But these are exactly the same identical problem you would have had if you enabled the bidirectional filter. So the only case where I imagine I could keep the snowflake schema is that I want to be able to browse purchases, I want to be able to browse sales, I want to be able to keep the model simple, and I don't enable the bidirectional filter, knowing that this limitation will not enable certain kind of analysis. Then at that point it could make sense, but otherwise I would go this way.
Okay, that's fantastic. We've had another question, which I think that we've covered it off in the YouTube video. I'll pose it anyway, but it's how to find the problem that is causing the slow performance.
Let's see. So
this is from Dren Gara.
I'm checking here. I don't see it. So can you repeat the question? I try to understand.
Yeah, of course. So it's more of a diagnostic piece. So how would you go about finding the cause of the slow performance within Power BI?
So you have to watch the video.
Exactly.
So the video is just about that. So usually I just try to recap in a few seconds what we try to say in 1 hour. First, make sure the problem is not just the number of visuals you have. And you can see that using the performance analyzer in Power BI desktop. Once you can exclude that the problem is just caused by the number of visuals, try to isolate the problem, trying to fix which is the visual that is producing the slower query time. And once you located that visual, within the visual, try to locate the single individual measure that is slower than others. Once you have that, start to do the optimization of the DAX code. But in order to optimize the DAX code, you have to know DAX very well, and then study how the query plan works, how the storage engine, the formula engine work together. We have a few chapters of the books, the Definitive Guide to DAX, an entire course on SQLBI.com. And really, I cannot explain in a minute what we. Oh, thank you. The book is this one. There are several chapters just about how to do that. When the problem is DAX, just don't assume that the problem is DAX. Sometimes the problem is not DAX, the problem is just something else. And so the goal of the video is just to make you aware how to exclude that the problem is somewhere else. Once you are 100% sure the problem is DAX, then okay, you can start to dig, into the DAX query plan.
Excellent. I'm going to try and give you a few quick fire questions, Marco. I don't think they are quite quick fire, but we can try. So this one's from Ben, and this is, why is the query engine using a left outer join where an inner join is faster, at least some of the time?
Because so let's say this. So if we are using the Vertipack engine, it doesn't matter. And there is no inner join. There are only left join in Vertipack. So assuming that the question is about direct query, in direct query, this is true. And we have an option to ask the engine to use the inner join. But you have to be aware that if you enable that inner join mode, you have a responsibility. You are declaring, I trust my data. Because if you can trust your data and you're pretty sure there are no rows in the fact table without corresponding rows in the dimension table, then it's fine. Be careful, because if this doesn't happen, you will have wrong totals, because any transaction related to a product that is not connected in the product table will disappear also from the grand total. Whereas using the left join technique, the left join technique is used just to make sure that in case you have a product key that doesn't exist in the product table, just to make an example, the grand total will be still correct. And all the values that are not related to an existing product will be grouped in a row that has a blank product name or product color or whatever, right? So this management of what we call these invalid relationships. So in an invalid relationship, you can still have good numbers for the grand total. For when you're not using that relationship, you still get good numbers. If you start to use inner join, that guarantee goes away. And now the real issue is that when you import the data, you always use left join, and it is fast, believe me. So if you switch between import mode and direct query mode, and you are not aware of the problem and you enable the inner join, you will see completely different, not complete, but you will see different results depending on the fact that the data is in memory or not. When you add to this, you are using aggregation over direct query, it's way worse, because when you have the aggregation, you see a number. When the aggregation is not used, you see another number. You don't want to go there, believe me. So if you know what you're doing, there is an option to assume that it's called assume referential integrity. You enable this option in a relationship, left join goes away, and you have your inner join. But you have to trust your data.
Fantastic. And I've got to say, hooray, we have a first-time book purchaser off of the back of this webinar. So thank you very much, Debbie. You're going to love the book. Okay, and Debbie also asked a question. And she asks, how much does being a pro workspace user opposed to a premium contribute to slowness, especially with obviously the release of Gen 2 or in preview currently?
It's hard to answer to this question. I would like to be able to answer to this question, because so let me try. I just want to. It's not one of the last questions, right?
There's quite a few left.
Okay. So I think, if I understand, I wanted to see if there is some other detail. But who is the person who asked the question?
This was at. Sorry.
I found it. Debbie.
You found it. Perfect.
How much does being in a pro? So let's say it's hard to answer. So from my point of view, probably not much. The difference between the pro and the premium is more visible when you in Gen 2. Is more visible when you refresh data. The refresh in premium is faster for technical reasons, because technically they use different machines and with different capacity. The pro user uses a shared environment, so it uses shared resources. But premium Gen 2 does the same. And it's not necessarily bad. I mean, it could be bad because in a certain moment you might have another query from another user that is consuming resources. But this happens also in premium. The difference is that in premium, Gen 1, you had a dedicated machine, virtual machine, for the users of that capacity, which could have been a problem because it doesn't scale more than that. Whereas now in Pro, you had shared resources across different tenants. Now, Gen 2 is much more similar to Pro from this point of view. But they improved many things, and you should not see slowness caused by other users. right? By itself, a single query. So if you say, Marco, I have the same model, I open this model and I run the query. Is it faster in Pro or in Premium? The answer is that if you see that it is faster in Premium, it could be just because they probably upgraded the hardware where you're running the Premium Gen 2 capacity or Premium per user. But this could be a random choice. It could be not consistent. It could be that you know differences in hardware could make a difference in performance. Not much. I would expect no more than 20%, maybe 25. Not much. But if you see bigger differences, it could be because of the workload applied on the server rather than that. Again, we don't have much details from Microsoft about how they scale up and out the workload, so I'm not able to answer. But from what I know, the Premium by itself is not faster at query time. It could be faster at refresh time. Yes, of course. The refresh time could be much, much faster for a number of reasons.
Okay, we tried to. We had Christian Wade on recently, and we tried to get as much information on Gen 2 as we could.
Yeah, nice.
Okay, so as we move on to the next question is from David, who has a large data model with a few Excel data sources, which when referenced becomes very slow. When duplicating, it went much faster. Wouldn't referencing be a best practice rather than duplicating? And is referencing a table expected to have better performance?
So I think we are talking about Power Query, right? Because and I'm not an expert in Power Query. From what I know, well, yeah, you're right. What you're describing is relatively strange, but I'm thinking there could be a difference between Premium and Pro, but I would say that it is strange that the reference, the duplicating it is faster because actually it runs the same code twice. So yeah, I would be surprised. I mean, overall, I would be surprised as well. I don't have an answer to that, unfortunately.
No, that's no problem.
You have to ask to some Power Query expert. Chris Webb probably knows more about that.
Yes, we'll bring Chris Webb here. Sorry.
Yeah. Keep the question for him.
Yes, that's no problem at all. As we move back to, actually, sorry, I'll go to somebody who hasn't asked a question yet. So let's go to Katerina. My Power report simply contains a lot of data. So 5 data sets sampled every hour for 3 years, and we want to add even more data to it. This might be the wrong venue for this sort of question, but would you be able to point me in the right direction to ask how to manage the size of my data sets?
So it's a long question because I would say that Power BI is not the right place to do the job. So first of all, if you have data coming in and you have to archive this data and then you have to show this data in a data set, the data set should be something you can regenerate from scratch whenever you want. So just the idea that you have data that's increasing every day, okay, this could be an incremental update, but if you're using the Power BI platform as a way to store data, to store historical data, I would say that it is the wrong choice. There are other tools that have this goal, and I understand that people use that because they don't have other choices, but again, Power BI is not designed for that. So my biggest concern is what happens if you have changes that require you to reprocess the entire data set. That is not sustainable, right? You enforce a very rigid structure for your data model, and that is not a good idea going forward. Moreover, I have seen a few rare cases where we had to refresh the entire data set because of some issue we had in some refresh, and that was the only way to restructure. So it could be also just a maintenance issue that could force you to do that. So I would suggest you to look at how you create persistent storage of data outside of Power BI. You can use a data lake, you can use SQL Server, you can use many other tools, but not Power BI.
Yep, totally agree. And if we move on to, we go back to our data modeling side of things. If we got a question from,
I would add, I should not, but today. I cannot say more, but today yes. You have to look elsewhere.
We can do. I'm going to take that as a semi-exclusive based on previous conversations. Fingers crossed. Disclaimer.
Yeah.
We got a question from David Martin, and it is: what if there are two dimensions using the same parent dimension, like a geographical grouping?
Yeah.
Is it still a good idea to change from to a star from a snowflake?
Definitely. Also because you have a big problem if you don't do that. Let me explain. This is a classical. These are my favorite questions because they are easy. I already know the answer. I don't have to think.
You've seen it so many times.
So let's say we have this situation. We have classical is we have the customer, we have the store, and we have the sales here. So let's change the color sales. So this is the fact table. This is the dimension table. This is the dimension table. Star schema, classical star schema is this one. Now, both customers and stores have city, country, address, everything, zip code, right? And in many relational database, we have this. Okay. Now, imagine for a moment that you created the model this way. Can you do that in a relational database? Of course. Can you do that in Power BI? Yes, but you cannot enable all the relationships. Because guess what? If you do that, you can, when you filter geo, how do you filter sales? By customer or by sales? Who knows? Right? So if you think about this, you have the country of the customer is one thing. The country of the store is a completely different thing. Country is an attribute of the customer, is not an entity by itself. Every attribute you have in the geo table is just a list of attributes that you want to apply to a business entity, but you don't have a country as a business entity, right? The business entity is the customer, the store. The dimensions are the business entities. What is geo? A set of attributes shared between different business entities. Well, when you have this situation, the right thing to do is extend customer, extend store, putting here your geo attributes. But again, once you expand, once you join these tables, you have customer with country, city, zip code, store with country, city, zip code. Now, store country is one column. Customer country is another column. Yes, the content is the same, but they are two completely different things. From a business perspective, are completely different concepts. And this is the right thing to do. Oh, Marco, we're duplicating data. No, data is compressed, don't worry. And this works in Power BI without having to create strange techniques to disambiguate the ambiguity that you would have in the other case. That would force you to choose whether geo always uses customer or store, and then you create another measure that uses store instead of customer. But what if you want to intersect the customer, the country of the customer, and the customer in the country of the store to analyze what are the customer buying in the same in store of the same country or in different countries? You cannot. This way you can. You can just create a matrix and you see the the comparison between countries of customer, country, and store just with a simple matrix. So or another visualization, of course.
Yeah, I think that's a very key point as well you touched on there, Marco, in terms of this is what Power BI is for, the VertaPack engine, whereby we're not too concerned about rows. It's more of a columnar database.
Yeah.
It's a great point.
Yeah.
Okay. Have you got time for a last question for us? I know that we've overrun. Okay, so just pick a good one. And I think it might be worthwhile because there are a couple that are going on to the size of data. And the question that we took earlier, the user was ingesting data from a data lake. So when people do get onto large amounts of data, so analysis service, for example, you can have 190 gigabytes in the model quite easily. With Power BI, we can't scale to as much. So when we do start to get into large amounts of data or big data, what's the best way of continuing to add data to your Power BI data model and keep the performance of a refresh still consistent?
So usually, okay, so let's say this. Let's split the problem between query performance and refresh performance, okay? Refresh performance depends on a number of things, but a good technique to improve the refresh performance is to use the incremental refresh, right? Incremental refresh allows you to cut the timing for the performance a lot, so the time for the refresh a lot. So that usually is a good idea. If you're not able to use incremental refresh for any reason, then of course you have to figure out a way to keep the amount of data you want to process within a window of time that allow you to complete the refresh, right? Because if you want to refresh daily, you need to stay within the 24 hours, right? Because otherwise you always are late of 2 days or something like that. But usually a few hours is the maximum. Power BI Pro has a limit of 2 hours for a refresh. Power BI Premium doesn't have that limit, but I don't remember if the limit is a few more hours or no limit. But I think that nobody wants to process something for more than 6-7 hours is too much, right? It's more than one night. And so if you reach that amount of data, you have to seriously think about why do you need that amount of data refreshed daily without incremental refresh. There are techniques to manage that, but again, we have to use not only Power BI, but also Tabular Editor, for example, or Visual Studio if you want to regenerate everything. Because one thing that few people realize, one reason why the incremental refresh is faster, even when you when you deploy the model, the first refresh you run is for the entire model. And if you look at the timing, it is faster compared to what you obtain when you disable the incremental refresh. Why? Because when you have the incremental refresh, you have partitions automatically generated for you. If you use Power BI and you publish a model without incremental refresh, every table is a single partition. Now, guess what? The data of a partition is read sequentially from Power BI. Now, if the same table with 100 million rows has 10 partitions because you have 10 years, now you have 10 partitions, 1 million rows each that start at the same time. Now, actually, not 10, we don't have 10 partitions running in parallel, but even though you have only 4 or 5 partitions running in parallel, this cuts the processing time a lot if your data source is able to, pull data quickly enough to feed multiple readers at the same time. So my experience, this is also for Power BI Pro. You don't have to go to Premium, right? In Pro, I obtain amazing performance just using this technique. But query time could be a problem because a simple sum for a column that has, let's say, 200 million rows start to be in the range of a few hundreds of milliseconds, which is not a problem by itself, but you have to figure out how many users you have, because think about this. At a certain point, you have not only a large model, you have many users. And if you start having some measure that is expensive for a single query, your model will not scale well, right? Currently, Power BI doesn't scale out for a single model. So currently, there is a node, and the node is loaded dynamically. But if you have too many users, you don't have multiple copies of the same model that is allocated in other models. So that could be an issue for a performance, the workload for a single node. But this is something that Microsoft could fix. So I will not be too much worried about that. The problem is that if you go above 1 billion rows, which is possible, you start having every simple sum start to be in the range of 1 second. And so you rely on the cache, but the cache has other limits. So you start to be in an area where having multiple users running at the same time with a large model, billions of rows, every query will always run in the seconds area, right? A single query. I mean, when you look at the report that has many visuals, there are many queries there. So you are looking for something that will run slow. Now, what can we do at that time? Oh, we have other optimization techniques, but we have to start to spend more in writing DAX code, writing more complex models, writing code just to hijack the calculation using a sort of manually aggregated table, and it could be complex. So I will try to keep the model, lower than. Let's say the limit for Power BI, the physical limit is above 10 billion rows. I think that it starts to be too slow. Even though technically it works, I think that the user experience is bad. And so I will try to lower the volume of data. Now, if you want to use direct query, because you say, oh, I have too much data, I cannot load, again, what will you do once you use direct query? You will create aggregations. What are aggregations? Are the same data at a different granularity. Of course, direct query enables me to go at the lowest detail when I want. True, not saying that, but depending on how much, the automatic aggregation that had been announced 2 days ago will evolve. As of today, from my point of view, you need a very, very, very good reason to go to direct query. And my experience, 80% of the times, direct query is chosen for the wrong reasons. And basically, they start having all the complaints about the performance of direct query. And when we ask why did you use direct query, there was a wrong initial decision. We simply import everything and we solve all the problems. So this is my experience, 80% of the times, 80% of the times. So only 20% of the times there is a good reason to use direct query, and then at that point you have to invest money and time.
Yeah, that makes total sense. And in your experience as well, Marco, just as a last piece, what would you say is the most common item that causes Power BI to run slow that you've seen across your experience?
Sorry, Power BI to run?
So for a Power BI report to be slow, what's the most common denominator that you see when you go to see a client?
You have to understand that I am representative of the clients, the customers who have a problem that usually they were not able to solve with the common cases. So I tend to see strange cases, right? Based on what I know, many times the problem is that too many visuals or bad data model. Bad data model is a very, very common problem. What I receive usually is already after a first screening of this type. And so we usually see problems in the way the DAX code is written. Many times there is a bad use of iterators, aggregations, and not good understanding of how the DAX language work, right? So these are the more common problems, I think. One problem I have seen in the last 2 years that is, I would not say very common, but we receive several requests of that because I said we get what is scale. Yep. Is the problem that was mentioned in one of the first questions. So having a lot of nested calculations that there would not be a problem by themselves, but because of the way they are built to reuse the same calculation in many possible conditions. And so in order to do that, they start to write conditional statement in these basic measures using everywhere. That start to be an issue, right? So sometimes just I'm not inviting you to duplicate the code and to use bad habits, but sometimes creating 10 levels of measure just to save a couple of sum is not necessarily a good idea. Remember, if you don't have any conditional statement, it doesn't matter. But as soon as you put an if or a switch statement in one of these measures, then the word changes, and it could degrade very, very quickly. And at that point, when the complexity is so high, I have seen something like 20 levels of nesting in a measure, and it is hard because the time you spend at that time to reverse engineer the formula and to rewrite the corresponding calculation in a different way is very long. And if I have to do that, my problem is that I don't know what are the assumptions I could make rewriting the code in a different way, right? So when you write the code, you have to keep in mind that you are not developing a program in C++ or in C# or in Java where you want to reuse everything. No, we are writing a report. And by its nature, in the report, there is some redundancy somewhere. So I'm not saying that you have to duplicate your code everywhere. I'm not saying that. But when you start to see that you start to write nested levels of measures and you put some conditional statement in the middle, you have to, there is a warning, pay attention, because that could be the source of some issue. As I said, it's not the more common issue, but it's something that when it happens so late in the development process, then fixing it is very expensive. So pay attention to that. And try to do some benchmark when you are still developing the initial part of the model, because doing that at the very end of the development, another problem. Don't use a small database to do your test. Use the real one. Use the real amount of data. You don't have the real data, create fake data, do something. You have to test the measure in the right conditions, because otherwise I have another, this was fast until we loaded the real data. Come on, you cannot test the performance with 10 rows. You need, if you know that you're going to get 10 million rows, put them, especially for the dimension. No, the problem is not the real issue is not the fact table, is always the cardinality of the dimensions, because you have iterators there, and there are the biggest issues usually.
Yeah, I think that's a great point as well, Marco, in terms of using the real data, and also what you mentioned there with benchmarking. For the participants, it's worthwhile noting that DAX Studio now ships with a benchmarking, so you can do 5 runs against a cold cache and a warm cache. So please do make use of that functionality. What I'll do, Marco, because I'm very conscious that we've overran with you.
I have to.
I know your time's precious.
I have to say, the other 2 questions I had were questions we already answered. We had a question about fact table over 100 million rows is best to use aggregations, and what I said about aggregations about direct query is still relevant. But the idea is that if you have 100 million rows, just import the data. Come on. I mean, 100 million rows can be imported in memory, also more. The problem could be the refresh time, but just because you have a long refresh time, using direct query could be, it's like saying, okay, I don't solve the refresh time now. The refresh time, I don't resolve the refresh time now, and that problem is a problem that nobody will see. I can see the problem, nobody else can see, or the DBA can see the problem, not the user. And I move the problem to a place where it is very visible to the user. It's not very smart. It's better to have a strong argument with a DBA rather than your CEO. So think twice. And the last question was, what is the best way to learn to optimize DAX? And as I said, there are many articles, videos we have, but basically the book, the video course are the best places. There are also a few white papers. If you look at query plan in DAX, there is a white paper we have on SQL BI, is a PDF you can download, but it's better to start with some theory at the beginning.
Oh, definitely. And as my friend Chris Wagner would say, Marco, thank you for joining us today as a data god. It's been a pleasure to have you with us. What I'm going to do is I'm going to capture some of the questions we didn't get a chance to answer in the chat, and I'll send them over to you because I know you like to make videos and blogs based on what people are asking. So
yeah, of course. Okay, good.
Thank you very much.
It was a pleasure. And
thank you for joining us.
I hope to see you soon in London.
Oh, definitely. I look forward to it. I look forward to it.
Goodbye.
Thank you, everybody, for joining us, because you could have been anywhere in the world, but you've been here with the Microsoft Power BI UK user group. Thanks again.
Thank you. Bye-bye.